Hey guys, it's Canfield. We're going to go over the extreme value theorem homework as well as the graphing of derivatives. So here we go. All right, it says in the four problems below, match the table with the graph. So if we look, this is our x value, and they all have a, b, and c, and they're just referring to these points here. And we'll notice, like on this graph, I have a cusp here, I have a sharp point here, and nothing really of note yet here. Here I've got a relative min, here I've got a relative max of a smooth curve. So I guess when I'm talking about these, even though this is a cusp and a sharp point, that's also a relative min and that's also a relative max. That's a relative min and that's a relative max. But if you look at this first graph, it says at point A, f prime is 0. That means at point A, it should be flat. Same with point B, it should be flat. So A is immediately ruled out because it's not flat here. It is a cusp. Cusp, yeah. All right, so because of that, I already know this can't be A. If I'm thinking about A, B, C, or D, I know it can't be A. I know it can't be D either. Its only possibilities are B or C. And that goes the same for 676. A, B, C, D. Well, A and D are immediately ruled out. And the way that we tell which one's which, well, it says at point C, f prime is 5. That's a positive number. F prime for this one at C is negative. That means for 676, at point C, we should see some sort of upward direction. At 677, we should see, at point C, we should see some sort of downward direction. Well, G, oh yeah, that one has an upward direction. That one has a downward direction. So 50-50, I'm just kidding, no, just kidding, let's see. All right, so this one says it has a does not exist, which is a cusp or a sharp point at A, and then at B, it says it has a slope of 0, which means we have a regular min or max. So it can't be A, it's gotta be D, and that negative slope there matches that negative slope there. Similarly, those both fail, and we have that negative slope. So, all right. Oh, let me circle those. Cool. Let's keep going. Ugh, my keyboard's in the way. All right, let's see. Let f of x is equal to x minus 2 to the 2/3. Does f prime of 2 exist? Well, let's back up. Does f of 2 exist? Let's see. If I plug 2 in, yeah, try again, Canfield. 2 minus 2 to the 2/3. Let's see, that's 0 to the 2/3. Does that exist? Well, it's 0 to a power, so yeah, it's fine. It's 0. So that does exist. Now let's check f prime. So if f of x is equal to x minus 2 to the 2/3, well then we can take the derivative of that. Let's see, we'll bring the 2/3 out front. We have our x minus 2. We'll subtract 1 from our power, get negative 1/3 times the derivative of the inside, which is 1. Okay. So I could rewrite that if I want as 2 over 3 x minus 2 to the 1/3. So, am I allowed to plug in 2? Well, let's see. Let's try f prime of 2. We get two over 3 times 2 minus 2 to the 1/3. So we get 2 over 3 times 0, or 2 over 0, or does not exist. So no. All right, wow, that shows my age. People don't really say that anymore. Okay, let's see. Show that the only local extreme value of f occurs at x equals 2. So what we need to show is that there's no other critical number except for 2. And then we also probably want to just double check that 2 actually is an extreme value. Just because it's a critical number doesn't mean it's an extreme value. Remember, like, if we were to have a picture that looked like this, so let's say like the slope right here is 0, but then it keeps on going down, and there's no actual upward direction after that, that right there that'd be a critical number, but it would not be extreme. It would need to go like up a little bit before it goes back down. Then we'd have a critical number here, and we'd have a relative minimum. And there'd actually be another critical number here to make it return back down. So, okay, let's see. Show the only extreme value of f occurs at x equals 2. Well, let me bring back in the derivative. So f prime, and remember, when we look at this derivative, we're trying to find when does 2 over 3 times x minus 2 to the 1/3, when does it either equal 0 or undefined? Because if I can find when it's 0 or undefined, then we have a critical number that we can then test. Sorry, I just got a text from my mom. All right. So let's see, x equals 2. So as we showed before, when we plugged in 2, we got undefined. So we know 2 is a critical number, and we just need to ask ourselves, are there any other critical numbers? So like I would look at the numerator and I'd see, okay, there's no x's in the numerator. That means there's no way the numerator can equal 0. So the whole thing equaling 0 is right out. And the only solution for the denominator, or the only 0 for the denominator, is 2. So 2's our only critical number, but that doesn't mean that 2's a relative extrema. So let me do our test. So I'm going to make a sign chart. I know 2 is critical, and then I'm just going to remind myself that this is f prime, so f prime equals that. So I don't want to test, I guess I'll test 1. I was just going to test 0. Whatever, we'll test 1, and then we'll test 3. Okay, so if I test 1, I get 2 over 3 times negative 1 to the 1/3. So the sign of all of this, well, negative 1 to the 1/3 is possible, because a negative times a negative times a negative will get us a negative. So that actually is negative 1, and we wind up getting a negative for the whole thing. Here we wind up getting undefined. So right now, our function goes like, meep, and then this is kind of a, I don't know what's going on. But remember, we checked earlier, f of x is actually defined at 2. So it doesn't like disappear. It's just going to be momentarily vertical, which is bizarre. Let's try 3. If I plug in 3, I get 2, oh, I get 1 in here. So now I get a positive. So it goes, whoop. Okay. So that means that what happens is it goes down, it goes whoop, and then it goes whoop, something like that. And okay, so that'd be an extreme value. So it says show, so I think we would want to write something along the lines of, since f prime changes from negative to positive at 2, we have a relative minimum, and there are no other critical numbers. You know, saying something like that, just kind of proving our case. Let's see. C. Does the result in part B contradict the extreme value theorem? Well, extreme value theorem says that if it's continuous, given any closed interval, there's going to be at least one high point and at least one low point. So I feel like I'm missing something. I'd love to hear from you guys if there's, do you feel like this contradicts the extreme value theorem? It doesn't, but like, I feel like I'm missing the question that this raises. It's probably something really obvious too. All right, let's see. Repeat parts A and B for f of x is equal to x minus k to the 2/3, replacing 2 with k. So in general, we can redo all this stuff with just any number, and that number will be the critical number. And it will be the only critical number for x minus k to the 2/3, including positives. Like if this wanted to be, if k, well, I guess k would technically be a negative number there, like if it was x minus -2, then -2 would wind up being our critical number. But remember that x minus -2 actually looks like x plus 2. So even in this situation, we'd have a critical number at -2, and it's going to be this kind of seagull kind of shape. All right. Let's see. Okay, 681, I'm going to definitely need to teach in class. So the thing about 681 that we really need to talk about is there is a way to calculate the derivative of x cubed minus 9x, the absolute value of it. And if your teacher had taught you that, that'd be awesome. In general, the absolute value of u, let's say f of x is equal to the absolute value of u. The derivative of this is equal to the absolute value of u over u. Wait. All right. Oops. So I'm glad I went and double checked that. I had it backwards. It felt wrong. So it's u over absolute value of u, and then we have to multiply by u prime. This is just a kind of a more general way. Instead of saying f of x is equal to the absolute value of x, the derivative of this is equal to x over the absolute value of x. So the reason we don't use this as the generalized formula is x's derivative is 1, so putting the times 1 on the end is kind of dumb. But over here, it's more serious. So let me just give you an example. Let's talk about, so absolute value of x looks like this. It's a v. All right. And then, so if we look over here, f prime here is equal to 1, and then f prime here is equal to -1. And if we kind of use that formula, plug any positive number in here, like, at x equals 3 over the absolute value of 3, yeah, that is equal to 3 over 3, which is 1. And then if we were to look at -3, then that gets us -3 over 3, which is -1. So this little formula will always work. We don't have to deal with any piecewise stuff. And it even works for, yeah, I had about 4 feet of lead coming out of my pencil there. It even works for things like if f of x were equal to the absolute value of 3x minus 1. So if we were to look at this, 3x minus 1, you know what? Yeah, okay. 3x minus 1 has a 0 at 1/3. And then I think it's going to be kind of steeper than our other one. Not super duper important, but really anything after 1/3, it's going to have a positive slope. Anything before 1/3 is going to have a negative slope. And it changes abruptly. There's that sharp point right there. So if we were to look at the derivative formula for this, it says f prime of x is equal to 3x minus 1 over the absolute value of 3x minus 1. When you write these, I recommend kind of darkening your absolute value bars when there's like a 1 next to it so you don't think it's an 11. Remember, a lot of times our greatest enemy is our own handwriting. This is not the full derivative, though. That's the derivative formula for that, but then I have to remember chain rule and do times the derivative of the inside, which is just times 3. So a cleaner way to write this derivative would be f prime of x is equal to 3 times 3x minus 1 all over the absolute value of 3x minus 1. So if we tried plugging in 1/3, we'll see that we get 0 over 0, which is an undefined, which, yeah, the derivative right there is undefined. It doesn't exist because it's a sharp point. But if we were to try something like 1, if we try plugging in 1, we would get a slope of 3 times well, we plug in 1 there, we get 3 minus 1, we get 2. Down here, we're going to get the absolute value of 2. We get 6 over 2, which is 3. If we were to try something over here, like, let's just try 0. 0 is nice and easy. So let's try f prime of 0. We'll get 3 times 0 minus 1 over absolute value. 3 times 0 minus 1. So that gives us 3 times negative 1 over absolute value of negative 1, which is negative 3. So it really only has 2 slopes. It either has 3 or negative 3. And we could plug in any other number, and it's going to wind up being the same sort of thing. Don't believe me? Try 1,000 numbers. Maybe then you'll agree with me. Okay, so offshoot done. If we look at this, they're asking if f primes exist. Well, let's see. Excuse me. F prime of this is going to be equal to x cubed minus 9x all over the absolute value of x cubed minus 9x times the derivative of the inside, which will be 3x squared minus 9. So, do those exist? Let's see. This right here says, if we factor the x out, we'll get x squared minus 9. We'll get x times x plus 3 times x minus 3. This is in their denominator. That means this, and this, whatever their solutions are, or whatever their zeros are going to be DNEs for our derivative. Oh, wow. It's those 3 numbers. No! All right. So but all 3 of those numbers are fine to plug into the original function. That means these are all critical numbers for us to test using the first derivative test, using our sign chart with this. And it's a big mess, but it's definitely worth checking out. Let's see. So we are going to have x up here. We'll have f prime down here. You know what? This is a really good example for us to use like a really detailed sign chart. So if we have x cubed minus 9x and then 3x squared minus 9 over absolute value of stuff. I'm writing that because what is this? Positive or negative or 0? It's either positive or 0 only. So that's definitely important for us to pay attention to. All right, so we already know the zeros for this are 0, negative 3, and 3, but I wonder, are there any extra zeros in the top? This is also 0, negative 3, and 3. This one, if I factor the 3 out, I get x squared minus 3. Oh, that means that this has 2 more zeros. X squared minus 3 is equal to 0. We can add the 3 to both sides. And we get x squared is equal to 3. That means that x is plus or minus root 3. Root 3 is 1 point, I don't care. So it's between 1 and 2. So when we're setting up our sign chart, we've got negative 3, well, let's say plus or minus 3, 0, and plus or minus root 3. So when I go up here, our farthest, let's see, we've got negative 3, and then I can pick a number, so I'll pick negative 4. Then the next one that we have is negative root 3. Then we have 0. Then we have root 3. Then we have 3. So something between those two is negative 2. Negative 1's between those two. And this is like a, are you serious? That's so much. Well, yeah. It's okay. So right here, if instead of kind of dealing with this as one big unit, we said that this is really x times x minus 3 times x plus 3 times 3 times x minus root 3 times x plus root 3 all over stuff. If we're going to take it like that, I can put each one of these things here. We have x minus 3, x plus 3, 3 times x minus root 3, and then x plus root 3. I can kind of look at those all together and then do my sign of f prime. So let's see, -4. Plug -4 in. I get negative, 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 negative. Negative times a negative is a positive, positive. My final sign is negative. Okay, let's try -3. Oh, that's 0, so the whole thing is just 0. Try -2. I get a negative, I get a negative, I get a positive. That's why you don't have 4 feet of lead coming out of your pencil. I get a positive, I get a negative, and I get, now this one's the close one, but -2 is bigger than root 3, so I do get a negative. So that winds up being positive because those two turn to positive times a positive, those two turn to positive. All right. Here we have a 0, and so the whole thing is 0. I made an error back here. Remember that was actually a DNE for our derivative, so let's just kind of, yeah. All right, let's see, -1. So remember, these 3 were issues, so let me just go put them in before I forget anymore. So 0 was also a DNE, and 3 was a DNE. Okay. Let's see, -1. Let's test. We get a negative, a positive, a negative, and a... That's a little bit more than 1, so left with a positive. So that's 3 negatives. That means the whole thing's negative. And then we move on to 1. And we get a positive, a negative, a positive, a negative, and then a positive. Whole thing's positive. Root 3, that was not an issue with the denominator, so root 3 is going to wind up being a 0 because of this guy, so whole thing is 0. Try 2, we get a positive, negative, positive. 2 wins, so positive, positive, the whole thing winds up being negative, negative, positive, negative. It's switching, it's alternating. Then we try 4. Hopefully everything winds up. Yeah, they're all positive, so it's positive. All right. Woof. So what does f look like? So f is going to look like going down. So at -3, in our original, it's defined. So it's going to be like that, and then there's going to be like a little like cusp or something, and then it's going back up, flat, down, weird, up, flat, down, weird, up. So down and up and down and up and down and up. And the question asked us to find the relative extrema. So relative extrema. So we're going to have mins at, let's see, -3 is a min. 0 is a min. And 3 is a min. Then maxes. I know we have 2 maxes in our class. Let's see how many maxes are in this problem. We have a max at -3. Is that where you sit? And then the other max, let's see, boom, Boom. The other max is at root 3. And now we have the joyous task of going back to f of x and plugging every single one of those in to find out what we get. Let's see, if I plug in -3, oh surprise, I get 0. If I plug in 0, oh surprise, I get 0. If I plug in 3, oh surprise, I get 0. Now these ones, okay, plug in root 3, negative root 3. All right, let's see. Negative root 3 cubed minus 9 times root 3 is equal to, So, this is equal to the square root of 27, which we can write as 3 root 3. So this is negative 3 root 3 minus 9 root 3. Oh, no. I didn't plug in the negative. So plus 9 root 3. So this one we get 6 root 3. And then on this one, when we plug in positive root 3, we get root 3 cubed, which is, again, it's going to be 3 root 3. This time it is going to be minus 9 root 3. Which is, negative 6 root 3, except then we take the absolute value and get 6 root 3 again. Last question on this side. The function v of x is equal to blah models the volume of a box. What is the domain of this function? What are the extreme values of v? All right. So, domain of this. The volume of a box. So let's just draw our box. The artistically inclined, hopefully you're not getting too mad at me for this. All right, that's some warping because of the flood last year. It's water damage. So let's see. I'm going to say this is x. I'm going to say this is 10 minus 2x. I'm going to say this is 16 minus 2x. This looks longer. Let's do 16 minus 2x here and 10 minus 2x there. It doesn't matter. Okay, so can I use 0 for x? That would be a box that is literally not a box. It wouldn't be tall at all. There'd be no height. And since there's no height to it, it's not a box. So x, you're not allowed to be 0. Can x be 1? Let's see. 1? Yeah, that's totally fine. So x could even be like 0.01. X could be really, really tiny. So x needs to be more than 0. And then can x be a billion? If it's a billion tall, that's totally fine. But then over here, 16 minus 2x, ooh, that's a super negative number. And we can't have a negative length to our box. So because of that, we look at these two and just see when they equal 0. If x were 8, that'd be a problem. So x definitely cannot be 8, and it can't be more than 8. But then if we look at the other one, x can't be 5 for this one. So x is really stuck between 0 and 5. So now if we're asking for the extreme values, so that's part A. Part B says, I guess it's not A, B, and C, whatever. Extreme values. So that's going to be your v prime, and we're going to have, it's just a product rule. So I'll take the derivative of the first one and leave the other two alone. Then we'll take the derivative of the second one and leave the other two alone. So the derivative of the second one's just -2. And then we'll take the derivative of the third one and leave the other two alone. That's also just -2. Okay. And I want to find the extreme values. So I would just plug in 0 for my derivative because there's nothing that's going to make this undefined. So I don't need to say dne or 0. That's not going to be a problem. If that's an issue, if you're not sure why there's no dne there, I'd love to talk to you about that. Let me know. So if we hop in here, then Oh, I wanted to factor, but I don't really see. I guess I can take a 2 out of everything here. So let's take a 2 out of everything. So that's going to be 5 minus x. It's going to be 8 minus x. Nope. So since that says -2, when we take the 2 out here, I'm just going to leave that as a -1. I'm going to write that as -x. I'm going to kind of combine those two. Then we have 8 minus x. Then we have, again, the same thing happens here. So minus x times 10 minus, 5 minus x. So this is one of those issues with doing, you know, nice little cancellations. We have a tendency to make silly mistakes as we go. So let me just double check. Did I divide every single thing by 2? I did this wrong. I did this thing wrong. All right. So let's talk about why this is wrong. This is a really good chance to talk about it. So if I were to redistribute this 2, this says 2 times that. I'm done using the 2. It doesn't then distribute to that one. Blah-de-blah. If I wasn't 31 minutes into this, I would restart the video. So let's look at that again. Let's just FOIL stuff out. There is a way to take a 2 out of everything. I'm gonna get it more simplified before I handle it. So let's see, we got 160 minus 20x minus 32x plus 4x squared. Let's see, now we have, this is a -2x. So that's a -32x, and that's a plus 4x squared. Here we have a -2x again, so minus 20x plus 4x squared. I have 3 of the 4x squareds, so that's 12x squared. Yep, that was a squared. Let's see, number-wise, we just have the 160. Then we've got 2040. 104? All right. So finding the extreme values of this, a couple ways to do it. I think dividing by 2 now is a great idea. Divide both sides by 2, we get 6x squared minus 52x plus 80. I can divide by 2 again. Can't, but why don't you just divide by a bigger number? Because I'm lazy. Yeah, I could have just divided by 4 at the beginning, but I didn't want to think. I just wanted to divide by 2. That's easier. All right. Well, gee, I don't know how to factor this. Oh, wait, I totally do. Because we do the 3 times 40, which is 120. So I need 2 numbers that multiply to 120 and then add up to that -26. Just so happens that -20 and -6 add up to -26 and multiply to 120. So that tells me that I can use decomposition here. 3x squared minus 20x minus 6x plus 40. I'm guaranteed that this is going to continue factoring since that worked. So 3x minus 20. Here I can take a -2 out and get 3x minus 20. So this factors to 3x minus 20 times x minus 2. And so then I can find my critical numbers. They are 2 and 20/3. So then when we go in and do our sign test, and this is where I can use this instead of having to use the big mess at the beginning. So I can say, let's see, 20/3 is a about 6 and a little bit. So 6 2/3. So that means that we'll put 2 here. We'll put the 20/3 here. We'll say 7's here. I'll say 3's here. I'll say 0's here to keep my life easy. I'll put my x minus 2. I'll put my 3x minus 20. And then f prime sine. So let's see, plug in 0, we get negative, we get negative, we get positive. Plug in 2, we get 0, so the whole thing's 0. Plug in 3, we get positive, we get negative, so that means the whole thing is negative. Plug in this, we get 0, so the whole thing's 0. Plug in 7, we get positive, then we get 21 minus 20 is positive, we get positive. So it's going up. Means f of x is going up, flat, down, flat, up. So extreme values, 2 20/3. So now I have to go back to the original function. Let's see. I go back to the original function. Say v of 2. Let's see, that is 2 times 10 minus 2 times 2 times 16 minus 2 times 2. Let's see, so that is 2 times 6 times 12. 144. So, extreme. We've got, Oh, I did way more than I had to. Silly me. All I needed to do was find the critical numbers. I didn't have to do a sign test. Oh well, doesn't hurt. So, because it's just saying what's the biggest volume we get and the smallest volume we get. That's where it's really important to read carefully and make sure that you're answering the question that it's asking and not the question that you want it to be asking. Politicians are really good at that, at answering the question that they want you to be asking instead of the question that you are actually asking. All right, let's see. Let's 10 minus 40/3. 16 minus 40/3. Let's see, that's 30/3, and that is 48/3. Uh-oh. I feel like I did something wrong. Because this is telling me that 20/3, I get negative 10/3, 8/3. I get a negative volume. Oh no! Oh, what did I do? Everything's broken. So, maybe 20/3. Well, 20/3 it says is the least we'll possibly get. Canfield, you could have remembered 20/3. This is more than 5. It's a domain problem. I can't have this. It gives me a negative side. I already knew that. If I had remembered that, I wouldn't have had to go through all of this. Right here, I could have said, nah, man, you can't happen. I wouldn't have had to do all this. I could have said, oh, okay, so 2. 2's the maximum volume we're going to get. And the minimum volume we're going to get, I can test either side of my domain. If I do that, we wind up getting a box volume of 0. So we could, our extreme values here our max of 144 and a min of, I think I might have glossed over that too quickly. So remember that our domain was 0 to 5. So if we go back in and try plugging in 0, I mean, we have an invisible box then. And if we try plugging in 5, we have an invisible box because those cancel those out. So because of that, I guess we could say I could have an invisible box so it can be 0, and I could have an invisible box so it can be 5. So our volume is somewhere between 0 and a max of 144. I hope this has been helpful. I'll do the back in another video.